So in this video, we are going to consider this example. This is very detailed. That's why I want you to really understand. Now, a car number plate consists of 3 different letters followed by different digits. So in total, there are 6 objects, numbers and letters, digits and letters. How many such plates are available, are possible? How many such number plates are possible? Assuming 26 letters, assume 26 letters and 10 digits. Assume 26 letters and 10 digits. So here the same principle is also being applied. You understand? And always take note of the word different, not repeating. Different. The moment you see different and not repeating, use the formula earlier, the formula for combination, as we have said. So here what you can do is that it's very simple. You just have to take the permutation for the number, because we have digits and then letters. So letter, how many ways can we write the letters in the can we write the letters, and how many ways can we write the digits as well? So here you have we want the plate should consist of 3 different letters. So we have total letters to be 26. Therefore that's the total, and then we are selecting this. If you select 3, how many will be left? If you select 3, how many will be left? If you select 3, how many will be left? So as I said, you take the total, and then over, you've selected 3 out of 26. So how many will be left? 23 factorial. You are done. 23 factorial is the same thing, because you have 26 factorial be 26 times 25 times 24. Now any number beneath 24 is 23, 22, and 23 factorial is also 23. So it will cancel everything, so you don't need to work to that extent to save time. And then you do the same thing also for the number. Then from there you use the counting principle. That's where we say that combinatorics deals with counting. So here, why are we multiplying? We are multiplying because it's a sequence. Okay, it's a sequence in the plate. The number plate has this sequence. Always there is letter and then digit, so it's a sequence. That's why we multiply. So please take note, anytime there is a sequence and then there's some connection, let's say there is some connection, there are similarities between numbers, we use the major principle of counting, such as multiplication. That's what we use in doing that. When there is a sequence or there is similarity, we use this. So since there is a sequence between the digit and since there is a sequence between the digit and then the letters, all we do is that we find the permutation for the letters differently, then we find the permutation for the digit also differently, after which we multiply. Another application of permutation is also scheduling tasks or event. Okay, determining the number of different sequences in which task or event can be performed. Now we all go for interviews. You realize that you form a queue. The first person is considered. First come, first serve. The first person is always considered. It is very, very crucial. So here permutation is also applied. So another example, the same thing. A student has 6 different subjects to study for an exam. So you can use yourself as an example. You have 6 different subjects to study for an exam. Yes, you have choices. You have your first choice. You have 6 possibilities. The 6 possibilities is that you can select, let's say the 6 subjects are biology, chemistry, physics, math, agric. general science, general integrated science, and then there are this. You have the first choice. You can decide to choose biology, you can decide to choose chemistry, you can decide. You have 6 choices. Now after one of the subject is selected, you are left with only 5 books left. So you have 5 possibilities. So you start 6 times 5 times, that's it. So that's what you. So here you realize that the R and then your N, they are the same, they have the same value. So just take one of them and then find the factorial. And as I said, factorial is always the set of positive integers that is equal to or less than the given number. Less than or equal to the given number. So let's proceed. Now we can also use permutation to tackle seating arrangement, especially when the seat is in circles and then when it is also linear. Now this one is very detailed. We will take our time and then analyze how they are going to be seated and do the calculation. We are going to analyze because these are some of the terms that you shall be seeing on your exam, especially final exam WASI. That's when people are arranged in specific seats, example in row or position where their placement matters. That is, the order of position is very important.